Hey, welcome back. This is now 4.2, Solving Systems of Linear Equations by Substitution. And so it's the same thing that we were doing in 4.1. It's just now we introduce an algebraic method for solving the systems. And why? Well, because if you aren't drawing your graph very well, if you don't have a nice ruler or whatever, there may be some question as to what your intersection point is, especially if it's like a fraction or something like that. I mean, good luck, right? Identifying it by sight. It's I don't know, right? So the method that they develop here is purely algebraic, and it doesn't depend on drawing something. And okay, so it's better than graphing. And I would never want you to graph to find the solution. I would always want you to use solving systems by substitution or by addition. I mean, not to say that graphing is bad, because sometimes it'll give you a good idea of where a solution might be. But anyways, this is a preferred method. Okay, so let's see what this is all about. We have question 1. They give us our system of equations. And now I don't care very much about graphing at all. I can kind of just throw that stuff in the trash. And so what do? I'm going to start by solving one of the equations for one of the unknowns. Here, the second equation is kind of already in the form I want, so I'm just going to borrow that. And then I dump that equation into the unused equation. Okay? In other words, do a substitution. So wherever I see y, I'm going to put 4x. Okay, so I leave x alone, and then I have plus y, but y is now 4x. Okay, so that equation there in step 1 means that y is 4x. I'm going to put 4x in for y. Okay, then on the other side I have 10. Once you get that, you solve it for x. That will give you your x coordinate. So I have 1x plus 4x's is 5x's. And then you can divide both sides by 5. And you have one of your coordinates. Then you take that equation, expression, and plop it back into your formula in step 1 there. Okay? So you'll have y equals 4 times 2. In other words, y equals 8. And our solution then will be 2, 8. The ordered pair 2, 8. And of course, if you plotted it, you'd have for that first equation, x-intercepts of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. That would be our first line. And then the second line, start at 0, up 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So that would be like this. And then you can see, well, this is kind of a guessing game, right? Just trying to find this intersection point. But now we'll have this method, and it does it mechanically for us. Okay? And that's the idea. Everything else is just kind of variations on this idea, different forms for the equations, and that sort of idea. Okay, so let's just keep plugging through a couple. Problem 2. Move this so I don't have to keep toggling over. Okay, so x plus 5y is 9, and then y equals 2x minus 7. So I'm going to use that second equation for my substitution, and then I take that and put it into the unused equation. If you put it back into itself, you're just going to get a true statement, because it'll be this, it's the same line basically. But here we go, x plus 5 times y, and I'm putting, instead of y, 2x minus 7. You have to put it in parentheses. And then on the right side, there will be a 9. Then you solve this equation for x. So x plus 10x minus 35 is 9. So I'm simplifying. X plus 10x is 11x. Minus 35 is 9. Add 35 to both sides. 9 plus 5 is 4. Carry the 1, so it'll be 4. Divide both sides, it'll be 11. So 1 the x coordinate is 4, and then you just take that and plop it back into your step 1 equation. So we get y equals 2 times 4 minus 7, which is 8 minus 7, which is 1. So the solution here is 4, 1. Okay, question 3 is a little different than 1 and 2 because now one of the equations is, in 1 and 2 we kind of already had one of the equations solved for one of the variables, so it's just y equals something, right? Here we don't have that, so let's investigate problem 3. X plus 5y is 13, and then 3x plus 5y is 19. So what do? Well, I'm going to take that first equation and solve it for x, and that'll give me something to do a substitution. So you can use either equation. The rule of thumb I have is kind of look for the variable that doesn't have a constant in front of it, right? So if you look at all the different variables here, have the x, the 5y, the 3x, the 5y. So what I'm going to do is pick the x because there's nothing in front of it. And if there was something in front of it, it would most likely result in a fraction. So you want to avoid the fractions. So that's my reasoning for working with that first equation. Okay, so I'm going to take that first equation and solve for x. Okay, so move the 5y. You get x equals negative 5y plus 13. Okay. Then I'm going to use this equation and the second equation. So you always substitute into the unused equation. So wherever I see an x, I'm going to replace it with parentheses, negative 5y plus 13. Okay. Then you're going to solve that equation for y. So first I simplify both sides. I have to distribute here. Combine like terms. Now I'm going to isolate the variable term by moving the 39 over. And finally, isolate the variable by dividing both sides by its coefficient. And I have y as 2. Then I just go back to my x equation, which I found in the substitution formula, basically, which I found in step 1. So x will be negative 5 times 2 plus 13, which is negative 10, plus 13, which is 3. So my solution will be 3, 2. Okay, so no big deal. One small note is for that last part where I'm back summing, step 3, you could take this y coordinate and plug it in anywhere into any of the original equations. You can plug it in there, you can plug it in there. If you did that, you would have into the first equation x plus 5 times 2 equals 13. So x plus 10 equals 13, so x would be 3. The problem is it just takes a little bit more work, all right? And it's more direct if you take the y equals 2 and dump it directly into your equation that you find in step 1. Okay, in my experience, that's much quicker and less of a headache. It's just you have to remember to do where to put it, right? Whereas if you plug it into one of the original equations, it's kind of like just toss it up there and put it in, and you should be able to get your answer, right? You can do it either way. I'm not going to penalize you if you decide to do it your own way, but just be aware my way is more efficient. Okay. What did I do wrong? Oh, wrong question. Yes. Yeah, already put it in. Right, very good. More of the same. Yes. Okay, problem 5. So in the last problem, I had that variable all by itself. It didn't have any constants in front of it, the variable x. In this problem, it's not as nice. So let's take a look. 3x minus y is 10. And then 7x minus 2y is 25. Okay. So again, the first step you're faced with is solving for one of the variables. And our variable terms, we have 3x, negative x, 7x, and negative 2y. I'm going to take the negative y here. I want to solve for that guy. Because again, it's a problem of avoiding fractions. And truthfully, sometimes it's, that's just the way it is. You're going to have to deal with the fraction. But for us, and these homework problems are so nice that we can usually avoid the fractions. And, avoiding fractions means less complication, less things to juggle, less potential for error. So I'm going to go to that first equation and solve for y. I'll have negative y equals negative 3x plus 10. But I still need positive y. I need y equals something. So I'm going to multiply both sides here by negative 1. And we'll get y equals. On the right side, I have to distribute the negative 1. So I have 3x minus 10. Okay. So now it's a nice form. I can do my substitution. I'm going to plop it into the unused equation. That'll be my second step. So I have 7x minus 2 times y, which is 3x minus 10. That'll equal 25. So I'll have 7x, and then I'm going to distribute here. So minus 6x plus 20 equals 25. 7x minus 6x is 1x plus 20 equals 25. Then I'm going to move the 20 over. Minus 20, minus 20. So we get x is 5. And then finally, I'm going to sub in to my first equation there for y. So I have y equals 3 times 5 minus 10. So that would be 15 minus 10, which is 5. So my solution will be 5, 5. Okay, so my goal is basically to avoid the heck out of fractions, and that's why I'm being so careful. A little bit of strategy goes a long way. In this problem, it's not an issue. It's kind of a non-issue because we have a nice y all by itself, a nice x all by itself, so you can pick either one and kind of chug through it. This one, I think, is going to be one of our unusual answer types, right? So we have, again, if your lines are parallel, you'll have no solutions. And if the lines are the same, you have infinite solutions. Let's see if this previous one was like this. I don't think it is. This one probably is. So for no solution cases, what you do is just the same program that I developed, step 1, 2, 3. And what's going to happen is that the variables will cancel. And you'll be left with a false statement. Okay. In the infinite case, it's the same spiel. The variables will cancel. But then you'll have a true statement resulting. Okay. So in that first case, a false statement, an example of that would be something like 3 equals 1. In the second case, for infinite solutions, an example would be like 1 equals 1. Okay, okay, so let's look at problem 7. In my system, x equals 9 minus 4y, and then x plus 4y equals 15. Okay, so that first equation is solved for x. So I go ahead and just recopy it. I'm going to plug that into the unused equation. So I plug that in right there. In place of x, I'll put 9 minus 4y, and then plus 4y equals 15. And there you see it already, right? So 9 minus 4y plus 4y, those cancel, and you just have 9 is 15. So that's a false statement. and that implies no solutions. So it's pretty simple when this happens. Just click on no solution, check answer. Not much work, right? Which is nice. Let's check this guy. Right, so problem 8. So I think this will be the infinite kind. We'll see. 10x minus 6 is 2y. So again, the first equation is kind of solved already for y, so I'll use that as my substitution equation. And then I plop that into the unused expression. So wherever I see a y, I'm going to replace it with 5x minus 3. So I have 2 times parentheses 5x minus 3 on the right. I'm going to simplify this and try to solve for x. So I have 10x minus 6. Distributing, I have 10x minus 6. Try to collect the x's on one side. And there it is. The x's are going to cancel out. 10x minus 10x is 0 x's. 0 minus 6 is minus 6. Negative 6 is minus 6. That is a true statement, so that'll be the infinite solution case. So the two equations are the same. So the set of all points that are on that particular line. Okay. Number 9. Let's try this guy. So 7x plus 3y is 0, and then x minus 4y is 0. So this time, you're looking at 7x, 3y, x minus 4y. I'm going to pick the x to solve for. That will allow me to avoid fractions. So I'm going to move the 4y over. I get x is 4y. Then you take that and plop it into the unused equation. So you have 7 times x, which is now 4y, plus 3y equals 0. And then 7 times 4 is 28. Y plus 3y is 0. That'll be 31, 28, 29, 30, 31. Y is 0. Divide out. And you get y is 0. So back sub that into the first equation there for step 3. So x will be 4 times 0, which of course is 0. So our solution is just the origin. Okay, number 10, that's one of those ones where you're going to try to solve for the first equation for y. It's negative y, so you're going to have to end up multiplying by a negative to get it cleaned up a little bit. Number 11, they're just adding more work to the problem. And I would advise first simplifying that first equation before messing around with it. So a rule of thumb, I guess, first get both equations, or any equation that's kind of a mess, into a usable form. So usually that means put it into the form y equals mx plus b, or the form ax plus by equals c. So in this problem, number 11, that first equation is kind of a bit of a mess. So what I would do is kind of extract it and then get it into that ax plus by form. So I'm going to distribute the 5, get 5x minus 10 minus y is negative 5, and then move that 10 to the other side. Okay, so you get 5x minus y is 5. And now it's something you can work with. So you have 5x minus y is 5, and then y equals 5x plus 5. So first, the second equation is solved for y, so let's just use that. And then plop that into the unused equation in step 2. So I get 5x minus parentheses y, 5x plus 5 is 5. And then I'm simplifying, and it looks like this one's going to be some sort of infinite or no solution case. Yeah, so 5x's, those cancel, so the variable cancels out, and here we have no solutions. It's a false statement, so no solutions. But the point of this problem is to first get your equation into a nice form that you can work with. Okay, problem 12. Both equations seem to be solved for a variable. You can, okay, so it's not a big deal. It's just don't overthink this one. 8y plus 11, and then x equals 5y plus 3. Okay, so I got two equations solved for x. I'm going to pick whichever one I want. Y plus 11. And then I substitute it into the unused equation. And what it looks like is basically you're setting the two equations equal to each other at the end of the day. So I'm replacing x with 8y plus 11. And then on the other side, you have 5y plus 3. And then just solve for y. So I have 3y plus 11 equals 3. Move the 11. 3y is negative 8. Oh, really? You're going to have a fraction on me, huh? That's 8, 9, 10, 11. Yeah, bummer. 3y is negative 8. Divide both sides by 3. So y is negative 8/3. And then step 3, you're back subbing into equation 1. So x will be 8 times negative 8/3 plus 11. So x will be negative 64/3. And 11, you think of as 11 over 1. And then multiply top and bottom by 3. So plus 33/3. And that will be negative 31/3. Which I would be surprised if that's right, but it happens. So negative 31/3, negative 8/3. Usually they come out nice, but there are fractional answers in here. Yeah, it's just the way it is. Okay. This guy has some decimals. You may want to multiply through to get rid of the decimals. It's not a bad idea to do that. So 13, I have 8x minus y equals 1,000. And then the other equation, 0.03x minus 0.06y equals negative 30. So I'm going to multiply that second equation by 100, okay, just to make it a little prettier to deal with. Okay, so the first equation I'm leaving alone. 8x minus y is 1,000. The second equation, if I multiply by 100, it'll move the decimal place 2 places to the right in each case. Okay, then I'm going to solve for one of the variables. It looks like the y is a good choice. It doesn't have a coefficient on it. So step 1, I'll take that first equation and solve for y. And I'll multiply both sides by a -1. So get y is distributing 8x minus 1,000. So there's my substitution equation. Now I plug it into the unused equation, so I'll have 3x minus 6 times y, which is 8x minus 1,000, equals negative 3,000. Simplifying the left-hand side, I'll have 3x minus 48x plus 6,000 equals minus 3,000. So I have negative 45x plus combining like terms. Move the 6,000. And then finally divide both sides by negative 45, 20, 200 maybe. 9,123 divided by 45 is 200. So x will be 200. And then back sub into equation 1 for your third step. And get your other coordinate. So it's going to be 200, comma 600 for your ordered pair. 600. Whoops. Put 6,000 there. All right. Here we got some fractions. So what I recommend that you do is not work with the fractions. Okay. I would multiply through both equations to get rid of the fractions. Okay, so what do we got? Y equals 1/3 x plus 2/3. And then y equals 5/7 x minus 2. Okay, so that first equation, I can multiply everything by 3. Okay, so I'll have 3y equals 3 times 1/3 is 1x, plus 3 times 2/3 is 6/3, which is 2. And then the other equation, I'm going to multiply everything by 7. Okay. So I have 7y equals 7 times 5/7 is 5x, and then minus 14. And then I'm going to solve that first equation for x. So I'm going to move the 2 over and then flip-flop the sides. Then I'm going to put that into the unused equation, the 7y equals 5x minus 14. So I have 7y equals 5 times x, which is 3y minus 2 minus 14. So I have 7y equals, distribute, 15y minus 10 minus 14. Simplifying, so I'm combining like terms, minus 24. Move the 15y over. So get minus 8y is minus 24. Divide by minus 8. So get y is 3. And then lastly, back sub into the first equation. Okay, so our solution seems like 7, 3. Okay, so again, whenever I see fractions, I'm going to multiply to get rid of the fraction. What you do is multiply by the least common denominator of the fractions involved. So problem 15, that first expression, or the first equation rather, the common denominator between those fractions is 6. Okay? So I'm going to multiply that first equation by 6. Okay? So 6 times x over 6 is just x. And if you need to write it out, you can write it out in your margin. 6 times negative y over 3. 6 goes in the 3 2 times, so that would be negative 2y. And then 6 times a half, 2 goes in the 6 3 times, so that would just be 3. And now you have it in a nice usable form, and hopefully things will work out, right? So I'm going to solve that first equation for x. So plus 2y on both sides. And then substitute that into the other equation. So the second equation, replace x with 2y plus 3. Combine like terms. Isolate your variable term. And then finally solve for y. Back sub into the first equation. and you're done. Okay, so it looks like -3, -3. Sorry about my handwriting. So answer. Got cap locks on. Off. -3, -3. Oops. See if that works. Yay. Okay, so that's the standard procedure for handling fractions. This guy, now we get it back into that issue where you have a kind of an unusable form. So when you have kind of a scrambled form, like in problem 11, you want to get it into either the y equals form or the ax plus by form. Okay, and that's the problem in this question. Let's see one that maybe is more. That's the last one, really. Okay, so we'll try 16. Okay, so I have 3x minus 4y equals 15 minus 2x, and then the other dude is 7x plus 6y equals x plus 5y is 47. Okay, so in that first equation, I want to get all of the x's and y's on the left side. I want the ax plus by is c. So I'm just going to move 2x to the other side, and that one's done. Right, so that'll be 5x minus 4y is 15. And the second equation, I need to move the x over. So I'll have 6 x's there. And I need to move the 5y over. So I'll have 1y there. And then on the other side is 47. Now it's in a nice form. I can solve that second equation for y. So I have 6x plus y is 47. Move the 6x. So you have y is 47 minus 6x. Sub that into the unused equation. So I have 5x minus 4 times 47 minus 6x is 15. And then I have to simplify, so I'll distribute. And eventually they'll force me to get my calculator out, but not yet. Carry the 2, 16, 188 minus plus 24x equals 15. Add like terms, so I have 29x minus 188. 15. Move the 188 over. 13, 0, 1, 203. So either I made a mistake or there's no way that divides. 203 divided by 29. Oh, it does divide. 7. Mistake corrected. All right, I'm going to put that into there and get step 3. Y is 47 minus 6 times 7. 6 times 7 is 42, so that'd be 5. Okay, so this dude is 7, 5. All right, the next problem looks like it's kind of going towards story problem land. Let's look at number 18. So they're giving you English, and you got to translate it into 2 sentences, and then it's going to be a system of equations. So, anyways, so the difference between 2 numbers is 6. 5 times the larger number is 8 times the smaller number. Write a system of equations for the 2 numbers. Okay, so the difference between the numbers is 6. That means just take x minus y equals 6. And then 5 times the larger number is 8 times the smaller. So the larger number must be x in my first equation, because x minus something smaller will be positive 6. If it was negative 6, then x would be the smaller number. So anyways, 5 times the larger number, 5 times x means equals 8 times the smaller, so 8 times y. Okay, so there's my system. All I have to do is solve it, and sure. So I'll solve the first equation for x. So x will be 6 plus y. And then I'll sub it into the second equation. So I have 5 times 6 plus y equals 8 times y. 5 times 6 is 30, plus 5 times y is 8 times y. Move the 5y over. So I have 30 equals 3y. Or if you'd rather, 3y equals 30. Divide both sides by 3. And you get y is 10. And then back sub for our x coordinate. Okay, so in the software you need to first write out your equations apparently. So make sure you're reading the directions. Then the other equation. Okay. Then the smaller number is 10. And the larger number is 16. Okay. So more of the same. It's another one of those. And then one of these. Okay, so this is the equilibrium solution for supply and demand models. Problem 20. Okay, so it's about gasoline, and they're saying the x variable. What is x? So the table shows the price of gallons of unleaded premium gasoline. For each price, the table lists the number of gallons per day that a gas station sells and the number of gallons per day that can be supplied. The data in the table described by the following demand and supply models. Demand P equals negative 0.004x plus 8. And then P is 0.002x plus 2. So P is going to be the amount supplied or demanded, the number of gallons supplied or demanded. And then X must be the price. Okay. Price per gallon. Okay, so when you have demand and supply, and you're solving that as a system, so we have P equals negative 0.004x plus 8, and then P equals 0.002x plus 2. When you solve this system, you're finding where the supply and the demand are equal. Okay, so you have to imagine yourself like a gas station owner, and you want to make sure you don't buy too much gas. Right, so if only a couple of people want gasoline and you buy truckloads of gasoline, then you're in a lot of trouble, right? Because you're not going to be able to pay off the guy that you bought the gas from. So you want the supply to equal the demand, and that's what you're doing in this type of problem. So we set both equations are solved, so we can do what we say is set the equations equal to each other. So using the program I've defined above, I'm going to start with the first equation, and then substitute that into the second equation. Okay. But it's equivalent to saying set the equations equal to each other. So you'll hear teachers say that as well. Okay. Then you can solve. So I'm going to move this 0.002 over. Move the 8 over. And then finally divide by the thing in front of x. Oops, you do not want to divide by x. It's bad news. Okay, and then go to your calculator. 6 divided by 0.006 is 1,000. Well, that can't be the price per gallon. That must be the number of units. So P is the price, sorry. And then X will be the units, the number of the gallons. Supplied or demanded. Sorry about that. So that kind of makes sense. P for price. Okay, great. Then get your p-value by back summing into this first equation. So that will be $4 per gallon. So the equilibrium quantity is 1,000 gallons, and the equilibrium price is $4. Okay. Complete the following statement. If unleaded gasoline is sold for basically $4 per gallon, there will be a demand for 1,000 gallons, and 1,000 gallons will also be supplied. Okay. Right, so I think that'll do it then for this section. And as usual, thank you for watching, and I will see you next time.